with the tooling web server. Oh no, sorry. Let's start with nginx because that's the first thing we want to do. Where is this? So let's start with nginx because we need to configure nginx to reverse proxy for this server. So let's do nginx first. So Bastion to nginx, and nginx has to be in private. So let's have got our launch template for nginx. So nginx launch template here. And what's the configuration? So this is the MIID. It's used this key pair. It has the security group configured network. Okay, now we didn't do now. I'm looking for like subnet configurations. Didn't we do anything like that? Okay, I think that's probably when we're creating the auto scaling. That's what we specify the network. Okay, cool. Let's go ahead and create the auto scaling then. So we're gonna name it P15 nginx ASG. Actually, no, sorry. Let's create the load balancer first. I'll tell you the reason why. Let's create the load balancer first. This is what we want to create first. We want to create this load balancer here because people from outside, they need to reach this one before they can reach the nginx. Yeah. And the reason we're using a load balancer here is because for high availability, we're going to have the same configuration in two different availability zones so that if one whole zone goes down, we always have one zone that is able to service requests. And load balancers would only route traffic to any instance that has healthy status. So if this one is unhealthy, it will never route traffic there. So your customers are not going to mistakenly go to a server that is dead. Okay? Promises. So let's create a load balancer. So what we want to create is the application load balancer. So we've talked about the network load balancer. And this gateway load balancer, I haven't used it at all. I think it's one of those new features by AWS, where it's for some specialized appliances. So if you look at here, it says load balancer when you need to deploy and manage a fleet of third-party virtual appliances that support Genevieve. Oh, sorry, Genevieve. All right, so that's what that, but I haven't used it before. So the focus really, and trust me, no one's going to ask you this at interview. I think it's a new thing. And if you say you don't know it, you don't know it, so it's fine. Now, application load balancer is our use case here because it's going to be at the layer 7 of the OSI model. So that means the communication is only on HTTP. Okay, this is the one I was talking about. If you were to create a load balancer for the Bastion, because this operates at the layer 4 of the OSI model, and it uses the TCP protocol. This uses the HTTP and HTTP as well. It uses TCP, UDP, TLS. So our use case is this, and that's what we're going to create. There's also a classic load balancer. You can see here it says previous generation. This was the load balancer that was the only one existing when I first started to use AWS, like the first use of AWS. All of these were not existing at the time. So it was just one load balancer, you just use it, but now it's been separated to like all these ones. The only time you would use this load balancer here is when maybe the use case is to use it with other AWS services that are old generation as well, or some legacy applications that for some weird reason can only use this load balancer. I always recommend not to use it for any new projects. So we're going to go with application load balancer. So I'll click on create, and then let's give it a name. So P15 external, right? So for those who are joining today, P15 is project 15. So we're just giving it a name for us to identify it. Project 15 external ALB. So ALB to show that we're using an application load balancer, not network load balancer. And then it's asking us, is this going to be internet facing or internal? So as you can see, already AWS is already helping us because we're still going to create another load balancer here, but this one is going to be internal, not public facing. So this load balancer here, no one is going to be able to reach to it from the outside, just like all the servers we're going to have in the private network. But the one we need here right now is the public load balancer. So yeah, we leave that as public facing. And then IPv4 or door stack. So door stack is like if you need IPv4 and IPv6, you use the door stack. But well, some people have already started using IPv6, but IPv4 is still like the de facto one that is being used for IP addressing, and for a long time to come, it's still going to be IPv4. So, and already it says they're recommended for internal load balancers. So if we were to use load balancers internally, don't even bother using stack. Okay, so I'll be busy. Don't make the mistake to default to select the default one. Okay. And then network mappings, because we've already mentioned that we need it to be internet facing. So it's giving us the options of the subnets that are already in the public, the availability zones. So, but what we now need to do is to select the zone that we need. So we already have the public subnet, okay, in this availability zone, and we're going to choose that. And we also want a second subnet availability zone so that if it needs route traffic across the two. And this is basically satisfying our requirements, okay, of two AZs. So we'll select the second one. It's already selected it for us, so public 2. And by the way, all these subnets, we've created them already. We've been working on this since last week. Okay, so IPv4 settings, AWS is going to take care of that for us. Now, security group, we don't want default. We already created our own security group. So you can see why all those groundwork that we did, they're now paying off because now we know what we want. We just select it. We've already put the rules there. The rule for this load balancer, for this load size, that everybody on the internet should be able to reach us. If this company that we're deploying for is only going to be servicing people in the US only, we can limit the security group to be only accessible to people in the US only. So that's geographically limiting the access. Now we have the listeners and routing section. So what does this mean? When the traffic comes, how does it know where to send it to? So it needs to listen on a port. And once you hit that port, it understands that it needs to send it to a target group. So we need to take which target we need to go to. And in this case, does anybody know which target we need to specify here? Does anybody know? Can anybody tell me?
HTTP and HTTPS.
That is the protocol, okay, which translates into the port. So HTTP is port 80. So if we're now to go on the website on port 80, we haven't configured HTTPS security and all that. Port 8 is fine for now, and we'll just leave it at port 80. I won't do 443 for now. I won't do HTTPS. We'll come back to do that. But where is it going to forward it to? Have a look at the architecture. This load balancer needs to forward traffic to who?
To the external, to the external from to the internal.
So this is, we're talking about the external. We're creating the load balancer for external now. So your customers have reached DNS. DNS has resolved it into our load balancer IP address. Now we've reached our IP address for the load balancer. But load balancer is saying, okay, I have this request. What do I do with it?
To go to nginx, because that is the one that.
That is very correct.
Yes.
It's meant to go to nginx, not Bastion. Someone said Bastion. Bastion has nothing to do when it comes to customer traffic. The only thing we're using Bastion for is administration, engineers to be able to do SSH into the server. That's the only reason we're using Bastion. Okay. So don't get confused. Bastion is for SSH to reach out internal servers. Now, what we are talking about now is the actual website. Just like when you go to diary.io, once it reaches, okay, so let's simulate something. So, all right. Now I'm going to do host, and then I'll put this. Okay, it doesn't have that command there. Let me do it on my laptop. There's a command called host, and if I do this, it doesn't like this. Oh, whatever. So let's do that. So you can see host has resolved into an address. This address is a load balancer. Okay, this address right here is a load balancer. It's actually not the one that is handling all of this, that you're looking at. This diagram here, this home masterclass courses, all these projects on the side, whatever. That load balancer knows nothing about it. Just receiving traffic and just forwarding it on to whoever has been configured to handle, rendering the pages. So now we've created a load balancer, which, well, we haven't created it, but we're still creating it. And ultimately, it's going to have its own IP address. Once people reach the IP address, it needs to send the traffic somewhere. And you already have the architecture telling you what's going to happen. So this architecture, you can see the arrow goes straight into nginx. And nginx takes the traffic, send it to the load balancer here, which is the internal one. And the internal load balancer here takes the traffic, send it to the web servers. So that is what we're doing. So we're just doing all the way boom, like that, like that, like that. Okay? I hope this makes sense. All right. So, but we don't have any target group yet.
Sorry.
Yes, go on.
The same way engineers and Apache renders load balancing and reverse proxy. I mean, the same way Apache and the engineers renders web pages coming from a request coming from a load balancer.
Yes.
Does it mean that in a main stack arrangement that that the, how do I put it, the back end server too that runs on Node.js can equally do this?
Of course. So if you have a backend that is Node.js, this is where you're going to put your Node.js application here. Your Node.js application is not going to be here.
Okay.
This is just going to take the request, forward it onto the web server, and then your Node.js knows what to do with it. Okay. So once the business back here, and then back to your customers, right? So it doesn't matter which technology is going on here. It could be Java, PHP, Perl, Python, Node, whatever.
So, but in the case
this is it.
In the case of main stack, does
it
mean that the express now sits where engineers is sitting? Is that what you're saying?
No. Your Express is going to be here.
Express, sorry. I was going to say React JS.
Okay. So
so would we take this what do you call this public subnet as part of the
So, okay, I'm going to answer that as well. Now, your React JS is what? Front end,
A front end, there is a front
right? It's
end.
just an application. So it's going to be here. Okay, it's going to be on these servers right here.
And Node.js.
Recording in progress.
So that's a application which is common. Sorry, that's a microservice architecture which is common within the whole Kubernetes stack. Running React, another one running Node, and they can connect to each other. Because it's an overkill having C4 large EC2 instance, and all it's doing is just running only React. That's like overutilizing, or is it overutilized? You're underutilizing, yes, your resources.
Is it possible to have like a form of um, architecture, like a diagram that shows um, like for the main stack, so that we have an idea of how that can be, the infrastructure is being set up, so that we just have an idea of what the thing is, it looks like in the real world. I know we're looking at this one, then, but from the question that I just was asked, is it possible to have like a picture of that, to just to be able to be familiar?
So you mean like the microservice that I just mentioned now?
Yes.
Where you have your React, and yes, you're going to have that.
Oh.
And we're going to have that in the Kubernetes side,
Okay.
like I said, because that is a huge one right there.
Okay.
Okay. So there is an architecture for that, because this is not the only architecture we're going to be working on.
Okay.
This is like, you know, AWS 101, right? So we're going to move into a little more advanced after this.
Okay. Thank you.
Okay, now to not answer you, I think my book in terms of DMZs and all that. So this is not a DMZ here. You can consider this more of a DMZ, because DMZ is demilitarized zone, right? It's a concept they use. All this concept you're looking at right here, they practice it mostly in the military before. So that's why it's called DMZ. So DMZ concept is exactly what we're having right here, whereby you have some servers in some private places where no one can actually get access to. You need some, DOM to be able to get into it. And that's what we're going to do with our nginx. We're going to put it in a DMZ, which in this case is going to be here, rather than have it in the public subnet. Does that make sense to you, Medo?
Sort of. Yeah.
Okay. All right. So now let's just what we're trying to do. We were talking about this. Okay, we're working on the load balancer and the target group. So we don't have a target group yet. So this is where the target group. So there's a section for target group. As you can see, we don't have any target group. Let me see if we can refresh. Okay, we can refresh it. So if I refresh share and select, it says no resource to display. So we can either click on this, it's going to open a new tab, create a target groups, or we can just go there and just do it ourselves. So let's create a target group. So now this target group, what it basically means is it's like a container where you can put your servers, okay? Your auto-scaling servers. So any server that auto-scaling brings up, it just like categorizes them. So in the case of nginx, these two nginx servers are going to form part of the target group, so that when the request comes, it just sends it to the target group. All right, that's what we're going to do here. So the type of target is instances. So you can target IP addresses, you can target Lambda functions, you can even target another load balancer. But in our own case, we're just going to target instances. Okay, so P15 nginx target group. Okay, and then the protocol 80, and then the VPC, will select our VPC. So this is the protocol version. So HTTP has 1 and 2. So mostly just like IPv4 and 6, mostly people are using HTTP 1, but a lot of applications have started seeing that are using HTTP 2 as well. But they all also have core compatibility, whereby HTTP 1 is still going to work. So we'll leave that as it is. Now, health check is very important, because this is what your load balancer is going to need to determine if the target is healthy or not. If it is healthy, it sends the request there. If it is not healthy, it doesn't send the request there, right? Now, you can have different things to use to check. So you can have like an HTML code, for example, and inside the HTML code, you can name the file, maybe something like health. In some cases, I've seen them use health Z. I don't know what the Z means, but it's like common pattern. So when you see it, don't be surprised. That's what it's doing. So, but what this endpoint does really is to check if it's alive. So every time your load balancer pings the server, if it finds this file, then that means the server is healthy. If it doesn't find it, then that means something is wrong with the server. Now we can also leave it at the root folder. So that means if you go to diary.i, for example, and you don't put all of that, it will still resolve into the website. Basically, that's the home page, the root page. Yeah. So that's what this / means. So let me put that back. So if we leave it here, that means it will always check the home page of the site. And if it's returning 200 status code, then that means it is healthy. So all this HTTP status code is something else you also need to be familiar with. So if you type HTTP status codes, so there's different ones. You don't have to memorize, all of them. There is certain common ones. For example, anything between 200 and 299 is success. So most applications will return 200. So if I go to, if I do curl -I, capital I, for example, and do diary.io. Now, the only reason why this is given 301 is because it is hitting the load balancer and it's doing a redirect, right? Well, if I was hitting the web server directly, it will give a 200 or 2 whatever. You can see here redirection messages. Anything 300, 399 means redirection. So that's the reason why diary.io was hitting 301, because you can see there is an nginx load balancer behind our servers. Now, so these are error messages. So anything 500, these are server messages, server error messages, client error messages around 400 to 499. 404, I'm sure you must have seen 404 a lot when you go to websites. And that's commonly when a resource does not exist. So for example, I know that technology, blah, 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 does not exist. If I hit that, it should give a 404. So this is a 404 error. We've just created a nicely designed web page rather than having some, bad program error message coming back from the server, All right, so that's about health check. So this is going to be checking this route all the time, and it's going to be checking for. We can actually configure what is success. So if we say anything 200 as success, make it healthy. Anything 300 as success, make it healthy. All right, so that's it. So tags, we can just give it a tag as well to say name, and we can reuse the same name there. Okay, and then so now we have targets. Actually, where is it? Target groups. Okay, no. So let me go back because it's showing an instance which is the bastion. Let me just go back first of all. Oh, actually, has it not created? Oh, I haven't actually created it. Oh, wait a minute. Let me just configure it again. Okay, next. Tags, name. Okay, it hasn't created yet. So it was trying to get us to select an instance to add a target group, all right? But this is not the instance that we want because the only instance running right now is the bastion. So we don't need that. So we don't have any instances yet. As it says, no instances added yet. So that's fine. So we'll create a target group. And now we have the target group. So this target group is a container right now. It doesn't have any servers in it. So if I go back to my load balancer setup and I refresh, now I have the target group select. So now, anytime we hit this load balancer, it forwards the request to the servers inside the target group. That makes sense. Okay, so tag as well, we can give a name. And what's the name of this load balancer? Okay, so this is everything. This is Marie. Are we happy with this? It looks like we are. And create a load balancer. So view load balancers. So this is our external load balancer and its provision. It takes a while. So while that is going on, let's quickly create second load balancer. So this is a application load balancer as well. But this time around, we're going to call this internal. Okay, internal, and we'll make sure we select internal for this. Okay, and then we select the VPC. We select the subnet, and the private subnet we want to use is the private 1 and private 2. Private 1, private 2. Okay, now what is the security group? We do have our security group, which is internal ALB. We'll select that. And the target group as well. So we need to create the target group. So which one are we doing now? The internal is meant to forward the request to web servers, right? Now, actually, and then to website. Okay, so let's create the target group for the web servers. Okay, so let's do that. Instances, P15 web servers target group. And then we'll select the VPC, leave everything as default, the protocol, the health check, next. There is no servers yet, so just create a group. So we have nginx and web servers, which is fine. Okay. Now it's time to, what's this? Oh, okay, no, let's now refresh and select the web servers target group. So let's finish up our load balancer, create load balancer. So now we have two load balancers. One is internal, the other one is external. So now we've satisfied this requirement. The next thing we now want to do is to create auto scaling group for nginx, auto scaling group for web servers. All right. So let's do that. Auto scaling. So let's do, so what we have right now is a auto scaling group for Bastion. So let's create the auto scaling group for nginx. Okay, so P15 nginx ASG. And which templates are we going to use? We're going to use our, where is it? Nginx launch template. It already has a configuration on the AMI. It knows which AMI to use when it's spinning up. The security group, we don't have to do anything. We've done all of that already. So click next, VPC. Always remember to select the correct VPC. And then our nginx servers has to be in private network. Don't forget. So private 1 and then private 2. Where is private 2? Private 2. Okay, so this satisfies, this nginx, but not in public subnet. So please don't get confused. This diagram is not up to date, so it is actually here. Okay, because we want our system to be really, really secure. So we don't want people to reach our nginx in the public subnet. Okay, and this is going across two availability zones represented also within public subnet 1 and 2. All right, so we have our auto scaling group configuration set. Next, and is asking us now, this auto scaling group, is it relying on any load balancer? Remember when we created our Bastion, it doesn't use any load balancer. The reason auto scaling needs to know if there's need to link it up with a load balancer is because auto scaling's job is to either scale in or out. When it says scale out, it means that we don't have enough servers running in the group anymore. It is now time to increase the number of servers. In the case of our nginx, from this diagram, we only have 2, right? So 1 in this availability zone and 1 in this availability zone as part of an auto scaling group, right? And our load balancer routes traffic to auto scaling group. For some reason, deleted these 2. Maybe someone stopped the instances and auto scaling had to delete both and bring new up. This information needs to be known by the
Recording in
click on this.
progress.
We could have created our own target and say register target. Right now, we only have 1 server running Bastion. If I selected this and I select include as pending below, okay, right now it's pending, and I just register pending target. You can see now the target group for nginx has this. So anytime the load balancer receives traffic, is only going to send it to this bastion. But that's not what we want. And we want to manually come and be doing this. We want the auto scaling to do it for us, so that if any time the servers get deleted and new ones come up, these targets are registered automatically. So this is very important thing. And to be honest, let me register this because it's not what we want. This whole exercise will make a lot more sense to you when you actually practice it yourself. So try to take this whole architecture and try to implement it. Okay? Yes?
I have a question. Can you take me to the diagram, please?
Sure.
Okay, here you say the engineer's server should be in the private subnet, that behind the internal load balancer. Am I correct?
Yes, you're correct.
Okay, then.
Actually, no, not behind the internal. It's actually behind the external. The external will be sending traffic to the nginx, and nginx will be sending traffic to the internal.
Yeah, but you said the server should be in the private.
In the private, yes. In the private, yes.
So how are we going to achieve that?
So that's what we're going to do now. So we're this, what are we doing here? We're creating an auto scaling group for nginx, right? Okay, so the way we're going to achieve that basically is the auto scaling group understands that when it's bringing up a new nginx server, it has to place it in the private subnet, and we've selected that here. If I go back, let's go to previous. This is where we achieve it by selecting private subnet. So you can see subnet, right? If we wanted it to be in a public subnet, all we have to do is just select public here. And anytime the auto scaling is creating the servers, it will just put it in the public subnet. Okay?
Yeah.
Hello, Gary.
So
Yes.
the auto scaling creates them in the private subnet.
Yes.
When the traffic comes from the public ALB,
Yes.
and it sends the traffic to where? Is it sending it to the private, the internal load balancer? Being that nginx is not in the servers are not in the public subnet, or they're in the private subnet. And if they're in the private subnet, they are behind the internal load balancer.
Okay, so I don't want you to see, in fact, let me use my diagram. I don't want the use of behind the internal load balancer can be confusing. So let me get my pad, and then we do a bit of diagram to explain this a little further. Okay, so let's get this up. All right, so what we have is, this is our external ALB, yeah? And then it sends traffic to nginx, okay? This is nginx right here. Nginx is inside private subnet, okay? Nginx receives the traffic, sends it to internal ALB. So that's why I don't want you to use the word behind internal ALB because it's not actually behind internal ALB. The fact that it's inside the private subnet does not mean it's behind. It's actually above internal ALB because this ALB is what then sends traffic to the web servers.
Okay. Okay, I get you now. Yeah.
Okay. So, and I'll tell you the reason why we had to put this ALB, this internal ALB. So here, so external ALB receives traffic, sends it to nginx, which is going to be here. And then nginx sends traffic to ALB here. Okay. And then ALB sends traffic to these web servers in auto scaling. So the only reason why we're needing this ALB here is because these servers are part of auto scaling. And with auto scaling, servers can die, they can come up at any time. And because ALB does, things like health check and all that, it's able to understand which servers within the auto scaling to send the traffic to. Do you understand? So you could think of it as a bit of an overkill, but that is only if there was no auto scaling. If there was no auto scaling and you have servers here, engineers can basically just proxy it over to the backend servers, dynamically, and we'll be fine. But because we're running auto scaling and the servers can be scaled in or out at any time, it just makes sense to also have another load balancer here so that we just have peace of mind. You understand? So that's the only reason why we have this here. And for those that are considering careers to focus on solutions architecture, these are the kind of things you need to really focus on and know. By the time you become familiar with multiple use cases, you begin to see the pattern. So don't worry too much about, oh, but how do you know this has to be here or this has to be there? It comes as a result of seeing different patterns. You begin to see common patterns when you've seen this use case, it's similar to that use case, and it all just begins to make sense to you. Okay.
So
All right. Yes.
in what manner does let's go back to that drawing again so that I can
Okay.
in what manner does this internal load balancer does is check on the LD and dead servers during auto scaling in and out? Is it as soon as a request is made, or does it do it intermittently with a time frame such that it populates its kind of table to know which route is live and which route is dead, something like that?
Yeah, that's a very good question. So it's actually stateless. So it doesn't need a table to keep the data or anything. It does it, I think, like every maybe second or every 5 seconds or whatever. It does it like that every time. It doesn't wait for requests to come through to determine which one is healthy or not. So I think you can actually configure it to say, okay, check the health of the backend servers every X seconds. But it has a default settings. I don't know what the default is, maybe 5 seconds, but let's assume it's 5 seconds. So that means every 5 seconds, you will see it always pinging the servers. If any one of them returns an error message or a status code that is not 200, or the configured status code that we want it to tell us, if it doesn't give the status code that it expects, it will automatically consider it dead and it will deregister it from the target. So it will never.
Yeah, is it right to say that it does it by way of broadcasting or something?
No, it's not. It's not by way of broadcasting. In fact, when we have our nginx configuration. I'll show you how it does it. It's you will see it in the logs of nginx as well, how it's pinging all the time. Okay, it's just sending. It's just like, let me show you. You know, here we've done curl. Okay, if I use v, for example, let me use capital I as well. So v is verbose, capital I is don't actually return the data. Just tell me if reachable, tell me the status code or not. That's the capital I there. Now, if I do this, you can see it hits the endpoint and then it's able to see 300. So 301. Now, if our expectation is 301, and if we get 301 success, then it's happy. This is healthy, right? Now, imagine if I did this and I put it in a for loop or while loop and say, while true or something like this, then curl that. You know, that means as long as this is returning what I want, just continue to send this curl command. Because what it's doing is exactly what this curl command is doing. It's just pinging it, sending a message to that endpoint to say, are you alive? Is it 301? Is it 200? The moment the status code changes to either of that, this while is no longer true. And then it reports and says, this is not healthy. And at that point, you know, it doesn't even register. Actually, it will deregister because auto scaling can terminate the instance and bring another one up. And once it's terminated, it gets deregistered from the target groups. Does that make sense?
Sure, sure. Thank you.
Good. Very good. I hope we don't have information overload today, because most of the previous sessions, you know, you guys say information overload. Let's take a break. Do you want to take a break, or should we just wrap up? We're not going to do our nginx configuration everything today. We'll finish all of that tomorrow. Okay. So today we're just going to finish up our architecture. We'll try and create our RDS and our EFS. That won't take time. And then we'll know that everything is configured. So tomorrow we'll just configure nginx, configure the web servers, send traffic, test it. And if time permits, we'll configure HTTPS as well. And then we're done. Yeah. So what were we doing? We were trying to, yes?
Sorry. Sorry, finally, I just joined the meeting today. So many things are a bit, I've been cracking my braces.
Is that Clement?
Yeah, I am.
See, I told you. I told you.
In fact, I was surprised when I saw that you guys have reached project 15. Okay, so what do you think I need to do to cash up for a lot of
so
stuff?
you have two options. It's either you watch previous videos. Okay, I think we have about 6 or more videos, I don't know, from past sessions. You either do that and try to catch up before next weekend, okay, or you just an exit from this batch, go and start learning on your own, and then plan to join the next batch starting in January. Those are options.
Okay, okay. Let me see what I can do before the next meeting. That's next week. If I can, because I can see that you guys have done stack implementation.
Yes. Although we jumped some things, we didn't do Ansible and those. We had to jump that because I don't see it as important right now. So.
Okay, you actually jumped some projects.
So we jumped all the way from project 6 all the way to 15. So we didn't do 7, 8, 9, 10, 11, 12, 13, 14.
Okay. Okay. I should. Yeah, I should.
So you can.
I thought you guys have done all those projects.
No. So what you might want to do is to watch the videos starting on project 15, which is the last 3 sessions. So you might want to watch that and then catch up, at least to catch up with where we are right now. And then later on, you can watch all those other projects 1, 2, 3, and all that. Yeah. Okay. All right.
Okay. What about the project that's supposed to be submitted?
You can carry on doing that. You know, I mean, after this session, you know, you can have a session with Solomon or Leke. They can show you how to submit your project and all that. There's an onboarding video also where you log in, which I made.
I saw that.
So you can you can watch that too. Yeah.
Okay, no problem.
That video is a bit still now. I have to update it, so I'll do that. All right.
Okay.
Cool.
Thank you so much. Yeah.
No problem. So what we're trying to do here, we're creating auto-scaling group for who? For nginx, I believe. Okay. Yeah, I think I came back to show the subnet. All right, so let's go back. Let's continue. So next. So this is where we attach it to existing load balancer. We already have load balancer for the nginx auto scaling, so that when the traffic comes from the load balancer, it knows where to route the traffic to. So existing load balancer is for nginx, so we're just going to select that. Okay, and this is where, you know, optionally you can configure health check. You know, it's also good practice to select both. EC2, if you read what it says here, EC2 auto scaling automatically replaces instances that fail health checks. So if any of your instances fail health check, it's going to automatically replace them. If you enabled load balancing, you can enable ELB health checks in addition to the EC2 health checks that are always enabled. So health checking the EC2 is one thing. Health checking the load balancer is another. That's why it's good to check that. And then health check grace period. So the amount of time until EC2 auto scaling performs the first health check on new instances after they're put into service. So when you put a new server into service, that is when auto scaling group launches a new instance. If you notice, when EC2 is coming up, you have these phases that it does initializing, it takes a bit of time, and then later on it says available 2.2 or something like that. Let me just have a quick look. Let's go to instances. And here, this instance states, you can see it's, this one, status check. It says 2/2 checks passed. And before it reaches here, you will see initializing. You know, that phase where it's initializing is not ready. Maybe it's running some scripts. It's just not ready to be serviced. Okay. In Kubernetes, we call it readiness and liveliness probes. So it's like having a readiness check. It's one thing for a server to be ready. It's another thing for it to be alive, ready for service. Because a server can be running, but the application is not configured enough to start servicing requests. So maybe you have some scripts like user data. Remember I mentioned user data last week, that you can have a user data, which is some shell script that you want it to run when the server is coming up. Assuming you have that, and sometimes the shell script can be very long. If it takes that shell script to complete maybe 5 minutes, you don't want auto scaling to immediately put that server in service as soon as it spins up its instance, because you know it's still running some things. So this is where you configure the period of time where it needs to wait before it starts sending its ping for health check. Because if it still needs 5 minutes to run the script and immediately it starts checking the health and it says that it's failing, it's actually failing not because it's bad, it's just because it's not ready. So that's like the readiness probes. This is not ready. So you can say, okay, don't check for health. the first 300 seconds is 5 minutes. For the first 5 minutes, don't check for health, just relax. After that, then you can start checking for health. So that's what that's saying. And then we can do enable group metrics, which this is good. It doesn't cost anything. So enable group metrics collection with cloud within CloudWatch. So CloudWatch is that part of AWS that you can use to, monitor things. You can create alarms, notifications. No, well, not notification, because another service, which is SNS, does notification. But alarms is like when you monitor something and the alarm triggers. So CloudWatch is where you can set up metrics. Okay, so we'll see that too, so since we've enabled it. So next, now for nginx, we need two, and then the maximum capacity. I don't know. Since we have two availability zones, so you always have to consider that. So if we always want 4 servers to be available, that means we're talking about 8. Because if you always want 4 to be available in one availability zone, then that means you always want 8 available. And in this case, it is a reverse proxy thing. We only need to talk to one at a time. So we need 1 in one availability zone. So that means 2 in both, okay? And the minimum capacity 2 and the maximum in our case is also 2. So there's no need to have more than that. But obviously, now that we have a load balancer sitting at the top of it, we can actually have more than 2. So I'm actually going to take that back, because we can have more than 2 because we have a load balancer now. It's not going to be sending the traffic to all of them at once. It's only going to be sending it to one at a time, So let's say traffic increases, there's more users. Maximum capacity give us maybe 10, because 5 here, 5 there. Minimum capacity 2. Desired capacity can also be 2, because if there's nothing, we don't want to unnecessarily be making spending easy to cost. But if we know that from day one we need more than 1 server to handle our request, then we can say, okay, desired capacity or minimum capacity can be more than 2. So I mean, these are things that you can make decisions, discuss it with the team, discuss it with solutions architects, discuss it with business analysts. So if you have business analysts, sometimes the business analyst will not understand this part, and that's your job as either a DevOps guy, solutions architect, to explain things in non-technical terms for them to understand. Because when you're telling them, because these are decisions that are made as a team. You don't just make these decisions on your own just because you have the power to control and put the figures there. These are decisions that are made and are documented. So you can have a Confluence page where they keep documents, and they know that this is the desired capacity, this is minimum, this is the maximum. If anything is going to change, the whole team will be aware, and it will be decided by everyone. Okay, so because every single change has an impact on the business, so the business has to understand what they're doing, right? So let's assume this has been decided by everyone, and this is where we configure our scaling policies. Well, we can decide to configure this and say average CPU utilization. Anytime the CPU utilization uses 90%, begin to scale. Now, instances needed this amount of seconds warm up before including in metrics. So similar to what we talked about, the warm up period when new server comes up. Now this is for the metrics, so that in terms of CPU metrics monitoring, this is the number of seconds that is needed before you start including it in metrics, because you don't want to immediately start including, otherwise you have bad data basically. So in the first, period that nothing is happening and you don't consider that, and because what's going to happen is if you miss this part and it triggers auto scaling, thinking that is actually 90% value, whereas it's not 90%, that's where the problem here is. Okay, so it's very important also to understand that, okay, I want to wait 5 minutes, okay, before I start including this as part of the metrics for CPU utilization. That's just what this is saying. Then this disable scaling to create only a scale out policy means that we don't want to scale in. Okay, so even though you scaled out, you don't want the situations whereby you delete instances. Once you scale out, you scale out, no scaling, you know, so that's if you want that. So I'll just leave that. I mean, there's no point not scaling in if the CPU utilization comes down to like 10%. Why do we want to keep more servers running? And then instant scaling protection. Okay, so this scaling protection actually here is also, this one is optional as well. So what this is saying is, now we're saying we want scaling, right? But when there is, because sometimes when you've scaled out and you have more servers, and for some reason, you now have a scaling operation where it now wants to reduce the number of servers. What's going to happen is if you enable this, it's going to scale in, but it won't terminate those instances because you may need to go in there and troubleshoot things. Maybe the reason there was scaling was because something outside of CPU utilization. I don't know. It could be for anything. It might just be a case where some data that gets stored on the server, you want to be able to go in and get them out before it gets terminated. You know, that could be a use case, but that's a bad use case because why would you want to keep, you know, data running on an EC2 instance within an auto scaling group? Ideally, you would have scripts that either does a backup into like S3 before the termination occurs. You know, those kind of things, you can see them happen. But anyway, these are just configuration things, just helping you to decide how you want your system to operate, basically. Okay, so let's click on next. So this is notification. This is fairly easy. If I were to click on notification, I can, so this, I created this afternoon. So it's something you can create on the fly as well. So it's just like a container to put your notifications. And then you can say, for example, let's say I selected this, for example, every launch, every terminate, fail to launch, fail to terminate, whatever, you know, you can send a notification there. Once it gets into this topic, you can then, the topic has configuration to send it to an email address. Okay, so that's what that's all about. But I don't need that, so I'll just remove it. Next, we can give it a tag. So this is name, and the value here is, what are we creating? P15 nginx ASG. Okay, so every time there is a new instance, target. So that's what this means. If you don't select this, the new instance will not inherit this tagging configuration. All right, so we have all this. This is just a review phase, and we can create auto scaling group. So now we have our nginx auto scaling group, and we should be able to see that start coming up here. Instances. If we refresh, you can see now it's initializing P15 nginx ASG. Now, this, if we were using something like Terraform, for example, we'll be able to control that, you know, now it's spinning up 2, but you can see it's not giving us either 1 or 2. So we just have to manually come and put it here. But if this was done programmatically, we would have been able to to tell it that, look, I need you to make it 1 or 2. Okay, so let's just wait. So what I want to quickly simulate here is this. If I select one of them, you would see that it doesn't have any public IP. So that means no one can reach out to it because it's inside a private subnet. Where is it? Subnet private. As you can see, this is subnet 1, which is in EU West 1A AZ. If I selected the second one, I'm sure you must have put it in the second AZ. You see, this is EU West 1B, and this is private 2. So auto-scaling is smart enough to know that, well, I'm creating 2 instances. There are 2 subnets that have been selected. It will just know that one needs to go into one subnet and AZ, and the other goes into the. It won't be stupid enough to put both in one. You know, that doesn't make sense. You know, if we had selected 3 subnets across 3 AZs, it would also be smart to know that if there are 3 servers, it will split them across 3 AZs. If there were 2, it would just place them in either. So one could be in 1A, the other could be in 1C. You get the gist, right? Okay. So let's try to connect to the server. Now, this is where we don't have a public IP to connect to anyway. So there's no way we can connect there. And if I come back to our bastion, so this is our bastion. I hope you remember. Let me exit this. So I'm now back on my laptop, and this is going on, yeah? Now I'm in the bastion. Now I want to go into my private IP, which I just copied the private IP. Same way we tried to do it previously, because we don't have the private IP address on this bastion. I mean, if I do ls on the .ssh folder, what you would see there is just authorized keys. And these authorized keys, if I cut that, I believe you still remember your Linux commands, yeah? You would only see the public key for the private key. AWS will not put private keys on servers for you because private keys is the only time you have it is when you download it the first time. And that's the one that we'll be sharing with each other. Ideally, private keys should remain private and not to be shared. Of course, you can work with teams and teams sharing with each other. I've seen that happen, but it's also a bad practice. Everyone should have their own private key and never share it. You can share public keys, okay? Now, we don't have the private key on the server. How do we go about it? We have 2 options. We can either create the private key here, at least we know it, so we can say id underscore rsa.pem, and then we paste the content in there. So that's option 1. I'm going to show you 2 options. So let me copy the private key. Okay, Obina is saying I should wrap up. Okay, we're actually going to wrap up shortly. Don't worry. Okay, so I'm going to paste this here. And don't forget to change the permissions, otherwise it will not work. chmod 400 on that. And now if I try to SSH into the server, SSH -I, and select this, and you can either specify CentOS at, or if you don't specify it, because you're logged in at CentOS, it will use your logged in ID. So if you don't specify it, it will still work. And this time around, now we're in to the private server. So you can see the IP has changed from 0136 to 10022. And 10022 is yeah, this one we've selected. So that's the first option to get into our private IP and private server. And now we can do our administration, we can install things, we can do all those kind of things. And by the way, if I try to do sudo yum update, let me quickly ask, is this going to work? Or let's say sudo yum install nginx. Is this going to work? Do you think this is going to work or not?
I don't think it's going to work because we need to update. We need to update.
Okay, so you say
I don't think he has a sudo.
Not gateway.
He might not have a sudo permit.
okay, so let's take one by one. So the first person said it's not going to work because it's not been updated yet. So that is wrong. I mean, if so, updates is good. Okay, so the fact that you don't update it, if the nginx is in the repository, it will still install it. It may just not install the updated version, right? So that's that. Then the other thing someone said was what?
You don't have a sudo permit.
Sudo private. What does that mean?
Permission to run.
Oh, sudo permission. Well, it does because don't forget it's the same image as the bastion that we use. You know, we remember how we took the image? We took the image from the market and we just created new images. So we're basically using the same image. And I think we've used sudo before. So sudo does work with it. Okay, so that is also not correct. Somebody mentioned NAT gateway. That is why it may not work if it doesn't work. So you have to understand that this is a private network. It doesn't have access to the internet. Internet does not have access to it. The only way it will have access to the internet is if the subnet has a root table that has roots through the NAT gateway. We've talked about this a lot, right? If the NAT gateway configuration is correct, it will work. If it is not correct, it will not work. So, because this happens a lot in the real world, and I'm going to hit enter now, and as you can see, it's not going through. It's just there trying. It just doesn't even know what to do, right? And if I cancel that out now, and I try to do sudo ls, you can see sudo is working, you know, so it's not as if sudo has any issues. If I do sudo update -y, what have I done wrong? Sudo, it says,
Yeah,
oh, sorry, yum. Oh, sorry. I think I'm feeling sleepy. That's why.
I think so.
Okay. So sudo yum updates, you know, it's still not able to figure it out. So it's because it can't reach the internet. If I try to do ping.io, it cannot reach out to the internet. This is like locked and proper. So I'm going to stop here today. We won't be able to do more, but I want us to troubleshoot this. I want to give you the thought process to troubleshooting this. Imagine if you met this, you were not part of the implementation. And trust me, this is a typical use case that you can also talk about at interviews. Some of the problems you face, you joined a company, the whole infrastructure has been set up. I mean, the engineers that were working on it, they're on holiday, and then you were faced with handling, I mean, they did a 2-day handover to you. And then when you log on to servers, you realize that some of the servers in the private subnet cannot download packages. You have to troubleshoot it and figure it out. So we're going to do that tomorrow. And I'll show you the thought process into, you know, figuring out. Because if something is not working, like, where do you even go? You know? So yeah. So let's see, what do we have now so we can wrap up? So we have our nginx and web service target groups. We have the Bastion and nginx servers running, which is nice. I mean, if we, oops, what's going on? How many servers do we have? Oh, we have how many nginx? 1, 2, 3, 4. I think that's the configuration of desired or whatnot. So this guy, maybe, I don't know, there's something going on with the CPU usage. It's scaling. Minimum capacity desired is 2, but it thinks we need more servers, and it basically just spun up a few more servers for us. That's okay. Just for you to, yes, go on.
I was gonna ask, is it all this, is it like can be automated with Ansible?
So actually, I know why we're having more than 4 nginx servers. You can see this one is saying terminated. It's terminating and spinning them up because they're failing health check. That's why. So I'm going to answer your question now. Just quickly. Let's go to target groups. Now, these target groups. Okay, so you can see it has registered the nginx servers in target group, but it's draining because this health status is unhealthy. You know, because we don't have anything configured there. We don't have any nginx server, whatever it's called. So yeah, this will continue to happen. It will keep on spinning up new servers and deleting them. Now the question is, can we automate all of it? Of course we can automate everything, every single thing, and that's what DevOps is all about. DevOps is all about building all these solutions, but not manually configuring them, like literally automating as much as possible, like 90%, 100%, whatever. Some things we cannot automate not because it's not possible, but because of we call them red tapes. So there are certain red tapes that are company specific, you know. So maybe in the organization, some servers you just cannot run scripts on them, you know, and you need to do something on them. So those ones you just have to log in manually, get what you want out, and you know, automate the rest. That can happen. But as much as possible, you know, everything is automatable. Now, whether to use Ansible to do the automation, another question entirely, because you don't want to use the wrong tool for certain things. Yes, Ansible can actually do most of these things. Ansible can create the VPCs, can create the servers, auto scaling. It can pretty much do everything. But originally, Ansible was not designed to do things like that. Yes, it has the capability, but it is not designed to do things like that, because if you start a project and you use Ansible only to do this kind of things, your project can go advanced over some years, after some years, and Ansible will start hitting a roadblock that it cannot satisfy certain use cases. In that case, all the work that you've been doing in the last 2 years, what are you going to do to them? Are you going to throw them away just because Ansible cannot do it again and start all over again and now start using something else? So that's why it's very important to choose the right tool from day one to do it. And the pattern that companies use for EC2 based solutions like we have, because this is EC2 based solution, it's not containerized or Dockerized or anything like that. For EC2 based solutions like this, you will combine Terraform and something like Ansible. So Terraform will do the whole infrastructure automation, but when it comes to configuring on the server, you use Ansible to do that, because that's what it's meant for. Ansible is a configuration management tool. Okay. So things like installing nginx, configuring nginx to do reverse proxy, installing the correct applications, deploying the applications onto the server, installing the tools, the dependencies, you know, anything that has to do with configuring that particular server, use Ansible for that. Okay. So Terraform builds the infrastructure, Ansible does the configuration, and that way everybody's happy.
All right, cool. Thank you.
Yeah. Okay. So, any more questions? Let me see. So we're just having termination, and you know, that's fine. I'm just going to scale them down so I can leave you to enjoy your night. and leave everything else to tomorrow. But at least we're making some progress. I
Yeah,
hope you agree.
yeah. Dari, I have a question. So on the architecture we are working with, so I would just like to ask, apart of a version host or referencing security groups to each other. I know a security group can reference a range of IP address. It can reference other security groups. So
Yes.
and it can reference an IP. So a part of this, suppose a scenario where you got a financial company. Suppose you got a financial company, let's say like insurance company,
Mhm.
and then they got some other branches. So now we deploy we've deployed our applications like our applications there on the private subnet. So for you to reach this private subnet, you need to pass through the version host, which is deployed on the public subnet. But now, thinking about performance and cost and time put together, is there any other means apart of those other two means that this application can still be deployed securely and we could give access to all those let's say subcontractors to query data from this example like a database without passing through all this other locking into version and then SSHing into the private or to the data tier? Is there another way
So
around
if I
it?
understand the question correctly, you're saying that I want to try to understand the architecture again. So you say you have how many subnets?
No, it's not a matter of something. What I'm just saying is that, for example, like what we have, let's just say uh, uh, let's say Dare.io
Mhm.
is a company and has it's a partner companies working with it closely,
Mhm.
and then you want them to share. Uh, so let's say your data is stored in the data tier, let's just say in the RDS, you have some very sensitive data you store there in the RDS,
Mhm.
for example. So you want them to be able to collect data from the RDS, but you don't want them you don't want them to SSH into and then
Yeah.
SSH into the
And then
private,
get
yeah,
it.
security group referencing to the other security. Apart of this two scenario, is there any other way that those partner companies can query data from your database securely
Directly.
without going to directly secure? Is there any other way we could make them to query data securely? Because I'm talking from a perspective of a financial
Mm.
company.
I,
So they have a lot of data back and forth, moving
yeah.
back and forth. So then putting it in place time, time is very
Yeah.
important
I
to
see
them.
what you mean. I mean, what you can do is you can create a proxy
Okay.
so they don't have to get into a bastion. So basically, when they are connecting with a URL, they're actually passing a proxy
Okay.
address. All right. So that proxy address is just similar to talk to nginx.
Okay.
Okay. So nginx, for example, can be the proxy. Okay. And then they connect there, and then this does like the reverse proxy to your database.
Okay.
Okay. So similar architecture that we have here, having some load balancer or proxy in a public subnet, you can also do that for your data layer as well, so that people can talk to your database directly, but your database is not in a public
Exposed.
subnet. Okay.
Yes.
And even AWS already has something like that. So if you're using the RDS solution, you can actually create proxies from within RDS. I believe you can do that. Maybe we would have to create the database first before you see the option to create proxy. But I do know that AWS RDS proxy. Yeah, you can see they even charge for it. So RDS proxy. Yeah. So this is something. So your RDS can be in a secure private location, but you can expose the proxy and they'll be talking to the proxy, basically. So that's what I can think of.
Okay, thank you for
Does
that.
that make sense? Okay, good. All right. So any other questions before we call it the night? Wow, it's almost 11:30.
All right, how do we get the previous videos for this?
Put it all together and forward it. So you should watch that in your email.
Okay.
Yeah. We're developing some new features, but I don't know if you guys are going to meet it in this batch. If you do, that's fine. If you don't, then I would just say you're just not lucky to meet it. But basically, we're developing new features so that we don't have to send the videos out from your dashboard. You can see your videos after every session. So it makes life easy for everyone. But these things takes time to develop software and all these things. So yeah.
Okay. The architectural diagrams that I saw the other time.
Yes.
Is there a way? The previous video would they be showing how to draw it? If I get to the previous videos, this architectural diagram, how do we draw it out?
In fact, I like that you even mentioned that, and drawing all these things is actually a good practice. Now, I'm not going to show you or teach you how to draw these things. It's fairly easy, but I can guide you. So I have designed that using a tool called Lucid Charts. Okay, but it's not free. That's the sad thing about it. You can use Lucid Charts. It has all the icons and everything ready to go, and it's really easy to use. But there is a free one that you can use, which is draw.io. I wanted to type draw. I'm typing direct.io. Draw.io. Okay. So this one is also good as well. It has most of the functionalities you need.
Okay. At least for a starting point, at least.
Yeah. So you can also use it to draw. Oh, come on. Let me just quickly put it up so you can see. Connect it. So edit. Create new diagram. In fact, let's see if it's cloud, AWS, there's some AWS architectures already. Create. Yes. And you can use it. So you can get started by replicating the same thing. Look at this, exactly what's going on here. Just try to replicate it. You can search for shapes. If you put VPC here, I don't know if it's going to bring it out. Oh yeah, see, VPC. So this is for NAT gateway. You can drag it. You can drag things across. You can connect them together. And this is like a connector. So it's a really good tool as well. So just try to learn. So for those who want to become solutions architects, you just have to know how to use these tools, right? Okay. So Lucid charts this, and if you're going for a solutions architecture interview, they can ask you which tool do you use to draw your diagrams. Imagine as a solutions architect, you can't even answer that question. And you know everything about VPC and everything, immediately that's the difference between, you can ask questions that you may not know just because you don't have the experience, right? Because they're close to working in it like you guys are doing now.
Okay. Thank you so much. So
Cool.
when is the meeting tomorrow?
8 o'clock. It starts at 8 o'clock.
Okay.
Tomorrow.
Okay. Thank you.
British
Okay.
summertime. Okay.
Thank you.
You're
Bye.
welcome. All right. So in the absence of further questions, thank you very much, guys. The videos will be sent out, and then we'll see tomorrow. Yes, Uzo, it is recorded. Good night.
Thank you.
You're welcome.
Recording stopped.